Okay, so we are going to take a look at 3.2, looking at the angle relationships that we had in the previous session and what happens when there's parallel lines. So we are going to start out with a postulate, meaning something we accept as true without having to prove it. And we'll notice today all of the postulates and theorems are going to start out the exact same way. So if two parallel lines are cut by a transversal, okay, so here's our example. We have A and B. Those are the parallel lines. And this is the transversal. So what do we know from this postulate? It says each pair of corresponding angles is congruent. So if those two lines are parallel, which angles are going to be congruent? So again, corresponding or on the same side of the transversal and in the same relative position. So for example, angle 1 is going to be congruent to angle 3. Also, angle 7 is going to be congruent to angle 5. We also have angle 2 congruent to angle 4. And our last pair of corresponding angles will be 8 and 6. Okay, next, if measure of angle 1 equals 3x plus 40, and 3 is 2x plus 70, find the value of x in each numbered angle. Well, what do we notice? I see these two lines are parallel to each other, and these two lines are parallel to each other. If we're looking at angle 1 and angle 3, the relationship is they are corresponding, therefore they are congruent. So I'm going to set 3x plus 40 equal to 2x plus 70, so we get x equals 30. Okay, then we plug back in. So angle 1, 3 times 30 is 90, plus 40 is 130. And angle 3 would also have to be 130. Okay, then if we look at angle 1 and angle 2, or actually, I'm sorry, angle 1 and this angle here, those are corresponding. So this would also have to be 130. So this would have to be 130. So angle 2 is 130. And then same thing here and here. This is 130. Therefore, if you look at angle 4 and 130, they make a linear pair. So angle 4 has to be 50 degrees. Okay, next we have our first theorem, alternate interior angle theorem. So if two parallel lines are cut by a transversal, then each pair of alternate interior angles is congruent. So here we have lines A and B again are parallel, and this is our transversal. So let's identify which are the alternate interior angles. So we have 2 and 6 would be congruent. The other pair would be 7 and 3. Okay, so now we're going to prove the interior angles theorem, and we're going to be using the corresponding angles postulate. So let's start off. What are we given? We have L is parallel to M. So I'm going to put the extra set of arrows to show that they're parallel. Now I'm trying to prove that angle 3 and angle 6 are congruent. So here's 3 and 6. And those are alternate interior angles. So now I can't use the alternate interior angles theorem in order to prove that those are congruent. I have to use something else, and that's why we're going to use corresponding angles. Now, I would probably use, so we want to look at a pair of corresponding angles that involve either angle 3 or angle 6. I'm going to use angle 3. So what corresponds to angle 3? Angle 7. So I'm going to say angle 3 is congruent to angle 7, and that is corresponding angles postulate. And again, what are we trying to get? We're trying to get 3 and 6. Well, what do we notice about angle 6 and angle 7? They are vertical angles. So I can say angle 7 is congruent to angle 6, and the reason is vertical angles theorem. And what do we notice next? We have angle 3 is congruent to 7. Angle 7 is congruent to angle 6. Therefore, we can say angle 3 congruent to angle 6 by the transitive property. Okay, next one, alternate exterior angle theorem. Okay, if two parallel lines are cut by a transversal, right, here's our parallel lines, here's our transversal. Alternate exterior angles, what's going to happen? Each pair are going to be congruent. So A parallel to B implies, so what are our alternate exterior angles? So angle 1 and angle 5, that's one pair of alternate exterior angles. Remember, alternate means opposite sides of the transversal, and they have to both be exterior. And then our other pair, we have 8 and 4. Okay, let's prove the alternate exterior angles theorem. So what do I know? I am given line L is parallel to line M. So here I'm going to mark these. This time, what am I trying to prove? I'm trying to prove 1 is congruent to 8. Now, I cannot use the theorem to prove the theorem, but I can use corresponding angles postulate. And now I can also use alternate interior angles theorem if I want to. I think I'm going to stick with corresponding angles. So let's look for a pair of corresponding angles that either has angle 1 involved or angle 8. I will use angle 1 and angle 5 this time. So angle 1 congruent to angle 5. That's my corresponding angles postulate. And we're trying to get 1 congruent to 8. So if I look at 5 and 8, those form vertical angles. So I know those have to be congruent. So that's going to be vertical angles theorem. And then again, what do we notice? Angle 1 is congruent to angle 5. Angle 5 is congruent to angle 8. Therefore, 1 is congruent to angle 8. And this is our transitive property again. Okay. Next, consecutive interior angle theorem. So this is the only one that's going to be a little different because corresponding angles were congruent, alternate interior angles are congruent, and alternate exterior angles are congruent when the lines are parallel. But when we have two lines cut by a transversal, our consecutive interior angles are not congruent. They are supplementary to each other. So that means 2 and 3 are supplementary. Okay, and 6 and 7 are supplementary. Okay, so they're not congruent to each other, they are supplementary to each other. All right, let's go ahead and prove the consecutive interior angles theorem. So again, we'll start off with a pair of parallel lines. And what are we trying to prove? This time we're going to try to prove 3 and 5 are supplementary. Okay. So what I think I'm going to do is to start is I'm going to start off with, again, how can I relate those two angles? So let's look at a relationship with either 3 or 5. I'm going to use the fact that 3 and 7 are congruent. Okay, angle 3 congruent to angle 7, and this is corresponding angles postulate. Now I'm trying to get the fact that 3 and 5 are supplementary. So if I'm looking at angle 5 and I'm looking at angle 7, I can say that those two, so angle 5 and angle 7, are supplementary. Why? Because they're a linear pair, and that's what we call the supplement theorem. Okay, so that means measure of angle 5 plus measure of angle 7 equals 180. That's the definition of supplementary angles. Again, if I can get 3 and 5 to equal 180, then there's going to be supplementary. Now I see angle 3 and 7 are congruent, so I'm going to change that to an equals, because that will allow us to use substitution property in the next one. So this is going to be definition of congruent angles. And now I can replace, right? If these two are equal, I can replace angle 7 with angle 3. So that's substitution. And therefore, that means angle 3 and angle 5 are supplementary. And that's definition of supplementary angles. That one's a little bit different. It has a few more steps. We do have to use that substitution and change everything into equals because we're working with those supplementary angles. Okay, let's see. Angle 1 is 91 degrees and angle 11 is 83. Now we only have lines A and B are parallel. So that means C is a transversal and D is a different transversal. So those are not all related to each other. Okay, let's start with the first one we're looking for is angle 6. Well, angle 1 and angle 3 have to be congruent because they are corresponding. And then 3 and 6 add up to 180, so this has to be 89 degrees. Okay, angle 8 also makes a linear pair with angle 1, so that also has to be 89. Okay, then we look at the other set. So if we look at angle 11, right, so here's angle 11. That's congruent to angle 9, which is 83 degrees, because those are corresponding along that transversal D. And angle 13, well, that makes a vertical angle to angle 11, so that's also 83. Okay, example 6. Okay, here's what we're going to do. What we're going to do is we are going to extend this line so that it makes a transversal. So this is 105 degrees, which makes this 75 degrees. And then if this is 125, that has to be 55 because they make a linear pair. So now what I want to do is I want to look at that triangle. So we should know triangles add up to 180. So if I add 75 and 55, I get 130. And this has to be 50. So X has to make a linear pair. So X is 130. Okay, last example, here we go. I am going to extend these lines that are parallel. And then I'm going to look at, I have two different transversals. So this is one transversal, this is another transversal. Okay. So that means when I'm looking at 5y and 120, those end up being consecutive interior angles. So that's going to add up to 180. So 5y equals 60, y equals 12. And then 2x and 108, these end up being alternate interior angles. So those are actually going to be equal to each other. And we get 54.